Hey, Earth Science, I want to take a second to explain this concept of redshift and how it pertains to a rapidly expanding universe in Earth Science. So, take a look here. Let's say, for example, that your mom asked you to go to Walmart in Lakewood. And you didn't really want to go, but you went. And you got there, you insisted on staying in the car, playing with your phone and listening to music, while your mom went inside and promised to be inside for only 8 minutes. So here's your family car. You guys only buy the best. There's you in there, waiting for your mom. And 8 minutes goes by, and then another 8 minutes goes by. So 16 minutes have now gone by, and you're starting to get annoyed. So you plug in the aux cord to start to play the music really loud. And you also, because you're so mad, you start to blow the horn in the parking lot. So what ends up happening here is sound waves are leaving the vehicle and traveling across the parking lot. Like that. Now, if anybody's in the parking lot, so let's put like a person right over here and a person right over here. These people in the parking lot are going to hear the sound at the same pitch because of the same distance from the car, and the car is not moving. So the wavelength would look like this. Sound waves would register to these people as sounding the same. So let's say another 20 minutes goes by and you are starting to get really, really mad. So instead of just playing the music and blowing the horn, you decide to drive the car across the parking lot. Not at anybody, but you're just driving it. That's going to change this scenario a little bit. So let's take a look at what's going to change here. So now that the vehicle is moving, we'll have it move in this direction. The sound waves in front of the vehicle are going to be compressed because the vehicle is moving. It's still generating sound, but it's compressing these waves. And behind the vehicle, they're being stretched like this. So to those same two people, the person standing in front of the vehicle will hear the sound different than someone that was to the rear of the vehicle because the sound waves are no longer the same. These waves here have a shorter wavelength, which means they have more energy because they're being pushed. And these ones here have a longer wavelength because they're being stretched out. And you have actually experienced this phenomenon before, I'm pretty sure. So this is called the Doppler effect, named after the guy that discovered it. His name is spelled like this. And if you've ever hung out on the side of a road, or if you've ever gone out to a mailbox to get your mail and a car is coming by, you probably have noticed that when the car is coming towards you, it makes one sound, and when it goes past you, it makes another sound. So the car will be like that. That is essentially the Doppler effect. The waves are compressed when the car is coming towards you, so it sounds to you to be at a higher pitch, and when the car goes by you, and it sounds to be at a lower pitch because the wavelengths are stretched out. So Doppler, you guys may have heard of this too in terms of meteorology. We use something called a Doppler radar, which essentially we shoot radar at masses of air and we see how fast they're moving towards or away from a location based on the same principle. But we'll save that for meteorology. I want to go to astronomy right now and tell you how this pertains to astronomy. So this applies the same too for visual effects. So if you're looking at something and it's moving towards you, it's going to have a more compressed wavelength of light, hence the blue or the violet end of the spectrum. And if something's moving away from you, you are going to have a more stretched out, or a redshift, they would call that. Something's moving away from you. So let's jump off to space for a second then. On Earth, we started to look through more and more sophisticated telescopes at things that were out in space. And to our mild surprise, just about everything we look at, like 99% of the stars, or put a galaxy up here, or a far distant solar system, everywhere we look, things appear to be at this red end of the spectrum, like this. For the purposes of earth science, they call this redshift, which is a noun, but you could also use it like a verb. They could say, well, this galaxy is redshifted, or the star is redshifted from the perspective of Earth. What this really means is that everything we look at is speeding away from us. Put a little asterisk next to everything, because it's not like everything, but almost everything, especially distant things. We do use redshift, blueshift to figure out if there's an asteroid or something headed towards us, but and then in the case that there is an object that's coming towards us, so I'll put like a comet right here, it will appear to be blue shifted if it's coming towards us. But almost everything else is redshifted. So redshift supports the idea that the universe is expanding because when we look out there, everything is moving away from us, and also moving away from us at an increased rate. So the further things in the universe are moving away from us faster than the closer things. You can kind of see from this little drawing here that I made. So this supports the idea of an inflation theory, or the idea that the universe is growing every single day. For you, you'll counter this from this word here, redshift, and it really indicates that things are moving away from us, that the universe is rapidly expanding. So I hope that clears some things up. If you have any questions, please email me.